Good morning, scientists. Happy Friday, April 24th. Let's look at Google Classroom. So today's video is going to take you through the Gizmo lab that you're going to do today. You'll see that it is attached here. You'll also notice that there is a nervous system study guide. This is optional, and it is again, like the last one, going to be worth 1 extra credit point. Unless you have 100% in science class already, then you don't need it. You can just do it for fun and for the joy of showing what you know. All right, so the lab that you're going to do today is called the Reaction Time Lab. And in your reactions, it has to do with your seeing and your hearing. They both impact your reaction. So thought I'd let Tim and Moby tell you a little bit more about how you see and how you hear.
Sound around you. When something creates a disturbance in the air, waves travel away from the disturbance just like ripples on a pond. Sound waves travel real fast, about 1,200 kilometers per hour. That's about 12 times faster than a really big shark. Let's take a close look at your ears to see how you hear sound. Listen carefully. If you had a see-through head, you'd look something like this. Your ear is divided into 3 parts. The outer ear, the middle ear, and the inner ear. The inner ear isn't really this big, but we've drawn it large so you can see it better. The outer ear is the part you can see. It's made of a rubbery substance called cartilage, and its little ridges bounce sound waves into your middle ear. The sound waves travel down the auditory canal and hit your tympanic membrane, or eardrum. The vibrations of sound make your eardrum vibrate, just like a real drum. The ear contains the smallest bones in your body, the hammer, the stirrup, and the anvil. Let's see them in action. The eardrum's vibrations are transferred to the hammer, which begins to move back and forth really fast. The hammer bounces against the anvil, which passes its momentum to the stirrup, creating vibrations in the inner ear. Kind of like Morse code. The inner ear is connected to nerve fibers that carry the signal to your brain. Your brain turns the signals into sound. That's what you hear. Some animals can hear much better than humans. Cats, for example, can hear high-frequency sounds that people can't even begin to detect. Hearing relies on a complex chain of events in your ear, and if parts of the chain don't work, deafness can result. Dear Tim and Moby, how are our eyes able to see stuff? I don't get it. Sincerely, Fausto. Well, believe it or not, your eyes work kind of like a film camera. Light tends to move in a straight line unless something reflects it or bends it. When light hits an object, it bounces off and is reflected into your eyes. Your eyes have their own light-bending parts called the lens and cornea. The cornea is the outermost part of the eye. It collects all the light that's bouncing off of objects and focuses it through a small hole. That's your pupil, the black spot we all have at the center of our eyes. The iris, or colored part of your eye, opens and closes around the pupil, depending on how much light there is. If it's dark, the pupil will open up wide to let in as much light as possible. Whoa. Right behind the pupil is the lens, which focuses light onto the back of your eyeball. The lens is clear and curved, and it can change its shape depending on what you're trying to focus on. It acts a lot like the lens of a camera. The back of the eye is coated with a special layer of tissue called the retina. The retina is kind of like the film in a camera. It's covered in photoreceptive nerve cells.
Receptors.
Oh, photoreceptive just means they're sensitive to light. Anyway, there are 2 kinds of photoreceptors on the retina. You've got about 6 or 7 million cones and more than 120 million rods. Rods are very sensitive to light. In fact, they can be triggered by a single photon. The cones are less light sensitive, but unlike the rods, they can detect color. No, I am not posing for color pictures. So the lens projects an image onto your retina where the rods and cones transform the light and color into electrical impulses. These are transmitted up your optic nerve and into your brain. There, your brain decodes the image, and that's how you see. Right, there's another way the eye is like a camera. When a camera lens focuses an image on film, it winds up upside down. And when the lens of your eye focuses an image on your retina, it also turns upside down. But when your brain processes the image, it flips it right side up for you. If that didn't happen, well, you'd probably fall down a lot more often. I'm glad you asked. Humans have pretty good vision, but some animals can see even better. Raptors, like eagles and hawks, have eyesight 10 times as sharp as ours. They can see their prey from 1,000 meters up in the sky. And believe it or not, the eyes of the giant squid are a lot like ours, with millions of rods and cones.
Okay. So clearly, it's because of your brain, how it interprets those impulses from the sound waves, from the receptors in your eye that tell you, the brain tells you what you're seeing and what you're hearing. On Monday, I'm going to give you some optical illusions, and you'll get to see how those actually work. Again, it's your brain. Amazing. Okay, so if you would open your Gizmo Lab, you're probably going to want to split screen this. So it looks like this. If you go ahead and pause it and get that out. I think some of you guys get into trouble when you click here. You want to choose log in. If you click here, you're only going to get 5 minutes. So you're going to choose log in. The username is AD student, and then any number. If you don't remember your class number, that's fine. Any number 1 through 20 should work. And then the password is Gizmo, and then log in. And I've got that in Google Classroom. You want to choose Darus 1, and then you want to choose launch. And it should take you here. So this is your Gizmo. All right, so on your Gizmo, I'm going to kind of split screen here too, so we can see both. All right. Okay, so Sally holds a yardstick in the air, and Mark gets ready to catch it when it drops, you know, kind of like this, that kind of thing. Ah! But they caught it. Mark tries to catch it as fast as possible, and the distances that the yardstick dropped before being caught are shown on the graph right here. What was the most common result? Write down what you think it was. If you said 15, you are correct. What was Mark's best result? If you said 13, because remember, the faster you catch it, the lower on the ruler that the yardstick it would be. So 13 would be his best. How many times did he catch it at 17? There. Twice. And at 15, 4 times. So if you had to summarize a number, Mark's results with one single number, what would you use? Go ahead and pause, think through it a little bit. So most kids probably picked 15 inches because it was the most common result, and it was also in the middle. All right, so what you're going to do today when you go to the gizmo is you are going to test your reaction speed. So if you look on the gizmo, you want to set it up, and it says press start on your directions, but you actually want to choose begin experiment. And then when you choose begin experiment, you're going to, you'll see the yardstick drop, and you're going to want to tap on the screen for it to catch it, and you want to do it as quickly as you can. So when you do that, you're going to wind up writing down your results on the lines here, right here. Fill those up. So those results form what we call a data set. What was your best result? Write it down. And what was your worst result? If you look at number 3, the range of your data is the difference, so that means subtraction, between the best result and the worst result. So what was the range of your data? So pick your best result, subtract it from your worst result, and this will be your answer. Now, if you click on show your results, which I think I have right here, your results are going to be right here. And then click on range and check your answer. See if you got it right. Okay, for activity A, you are going to choose, click the target stationary. So you're going to, right here, click the target, and you want stationary. That means it's not going to be moving around. You're going to want to choose reset so that you start everything all over, and you want the list display. So here's the display, and you can see they have all different kinds you can have there. You're going to choose list. All right, so then you'll just go through and read the directions very carefully, answer the questions, and when you move on to number 5, you'll see that it now is asking you to select the dot display. And again, here is the dot plot. And then it's explaining that one way to describe a data set is the mode. So the mode is the number that shows up the most in a list. You can actually have more than one mode. You may have talked about this in math when you're doing your statistics unit, perhaps. So if you had a set of numbers and there were 2 19s and there were 2 6s and there was only one of all the rest of the numbers, then you could have 2 modes there. So here it's asking you, what was the mode of your stationary target clicking experiment? So what you're going to do then is it's asking you to write down what the mode is, or the number that showed up the most, and then what was the mode of your moving target clicking experiment. Do you think the mode is a good way to summarize it? So then, as you see, it's going to be really important for you when you do these gizmos to read every single word of every direction. I've highlighted some things here. If it's in bold, it's a setting that you have to change on the Gizmo app. So when it says show statistic, it's right here. And then it says select mode, and you'll click there. Okay? So these are all of the different settings that they're going to be having you work with and change and move. And again, in the video here, I'm pointing out show statistic. It's right here. Mode, this is where you would select that. My head is covering up the display, but this is where you're going to change the displays.